Regression analysis under exact linear restrictions. Consider a multiple linear regression model with k explanatory variables. It means xi's are where I is from 1 to k means x1, x2 and so on xk, k explanatory variables. Since we have an observation, so it means ki yi equals to beta 1, beta 2 and so on beta k are the coefficients of explanatory variables. So yi equals to beta 1 x1i plus beta 2 x2i plus and so on plus beta k xki plus ui. I takes value 1, 2, 3 and so on small n. So y we can also write it in matrix form. Y the column matrix of elements y1 y2 and so on yn, and the matrix of order k cross n x11 x21 and so on xk1 x12 x22 and so on xk2. Similarly x1n x2n and x and so on xkn. And beta is column matrix of elements beta 1 beta 2 and so on beta k plus disturbance term of elements column matrix of elements u1 u2 and so on un. That is y uh, equals to x beta plus u, where y is column matrix of order n cross 1 and x is a matrix of order n cross k, and beta is a matrix of order k cross column matrix of order k cross 1. Therefore x beta will be the matrix of n cross 1 plus u is the column vector of order k n cross 1. Consider a multiple linear regression model y equals to x beta plus u with the exact linear restrictions on coefficients r beta equals to small r, where beta is column vector column matrix of order k cross 1 and r is column matrix of order q cross 1 and small r, which is, and capital R is a matrix of order small q cross k. Q is the number of restrictions and R is known restriction matrix of order q cross k, capital R, which is known restriction matrix of order q cross k, q cross k, and small r is known vector matrix of order q cross 1. We use the least square estimate to estimate the parameters. The SSC sum of squares due to error is defined as SSC equals summation EI square, which is equals to E dash into E dash E, which is equals to U cap dash U cap. U cap dash equals to Y minus X beta cap R dash, and in another bracket Y minus X beta cap R. This is the equation 1, where beta cap R is the restricted least square estimate of the beta. And we have a restriction on the coefficients, linear restrictions on the coefficient, which is r beta equals to small r. This is the equation 2. So we have to minimize equation first, which is SSC, with respect to restriction, which is equation 2. For this we use Lagrange's method of multiplier of maxima and minima. So define S equals to SSE minus 2 lambda dash in bracket r beta minus small r, where 2 lambda dash minus 2 lambda dash is the Lagrange's coefficient of multiplier, coefficient of Lagrange's multiplier. So lambda is column vector of Lagrange's multiplier. S equals to y dash minus beta cap r, beta cap dash r beta cap dash r x dash in another bracket y minus x beta cap r minus 2 r beta cap r minus small r to whole dash lambda s equals to y dash y minus 2 beta cap dash r x dash y plus beta cap dash r x dash x beta cap r minus 2 in bracket beta cap r dash r dash minus small r dash into lambda. This is the equation third. We have to differentiate s with respect to beta cap dash r and equate it to 0. Then we will get 2 in bracket x dash y plus 2 x dash x beta cap r minus 2 r dash lambda equals to 0. It means beta cap r equals to x dash x inverse whole inverse into x dash y plus x dash x inverse r dash lambda. Since x dash x ka inverse into x dash y is beta cap, so beta cap r equals to beta cap plus x dash x ka inverse r dash lambda, where beta cap r is restricted least square estimate. Del s by del lambda equals to 0. Another equation. This implies minus 2 r beta cap r minus small r equals to 0. So r beta cap r equals to r beta cap plus r in bracket x dash x का inverse r dash lambda. So from here now r beta cap r equals to r beta cap plus r x dash x का inverse into r dash lambda. Here we have put the value of beta cap r, means the estimate of beta, restricted beta. Okay, so r into beta cap restricted equals to r beta cap plus r x dash x का inverse r dash lambda. So from here we will get the value of lambda. So r beta cap so r beta cap plus r x dash x का inverse whole inverse r dash lambda minus small r equals to 0. This implies small r minus r beta cap equals to r x dash x का inverse r dash lambda. So lambda equals to r x dash x का inverse r dash का whole inverse into small r minus r beta cap, which is the value of lambda. By putting this value of lambda, means lambda in terms of estimated beta cap, not it is not a beta cap only, not restricted beta, it is only beta. And putting this value of lambda in beta cap r restricted beta cap. Okay, by this we will get the value of beta cap r in the simple terms of beta, simple beta. So beta cap r is restricted least square estimate, mean and variance of beta cap r. Since beta cap r equals to beta plus x dash x का inverse r dash in bracket r x dash का inverse x dash x inverse r dash to the whole inverse into small r minus r beta cap. So expectation of beta cap r equals to expectation of small beta cap plus x dash x का inverse r dash in bracket r in bracket x dash x का इनवर्स r dash का होल इनवर्स in bracket small r minus r into expectation of beta cap. Since r into expectation of beta cap will give beta only, so small r minus r beta equals to 0. Therefore we will get expectation of beta cap r equals to beta. So unbiased estimator of beta cap r means restricted least square estimate of beta is unbiased estimator of beta only when restrictions are correct, means small r minus r beta equals to 0, then only. Since beta cap equals to x dash x का inverse into x dash y, this implies x dash x का inverse x dash in place of y x beta plus u. By multiplying with x beta plus u, we will get beta cap r equals to beta plus x dash x का inverse x dash u plus x dash x का inverse, because it is the value of beta cap in terms of beta. You have put this value in the place of beta cap, and then the next term x dash x का inverse into r dash in bracket r into x dash x का inverse r dash out of bracket inverse in another bracket small r minus r in bracket the value of beta cap, which is beta plus x dash x का inverse x dash u. So in the value of beta cap restricted, we will get in terms of beta cap, and in this value of beta cap restricted we replace the beta cap by beta, then we will get this value. So beta cap r minus beta equals to x dash x का inverse x dash u minus x dash x का whole inverse into r dash in bracket r into x dash x का inverse r dash out of bracket inverse r into x dash x का inverse x dash u. So beta cap minus beta equals to in bracket I minus x dash x का whole inverse r dash and in bracket r into x dash x का whole inverse r dash to the whole power inverse r and x dash x का whole inverse x dash u. So since this term in bracket is m taken as m, which is a matrix, so m into x dash x का whole inverse x dash u, which is beta cap r minus beta. So variance of beta cap r equals to covariance of beta cap r, which is equals to expectation of beta cap r minus expectation beta cap r, and in another bracket beta cap r minus expected beta cap r to the whole power dash. So expected beta cap r equals to small beta cap, small beta only, not cap. So expectation in bracket expected beta cap r, sorry, expectation in bracket beta cap r minus beta in another bracket beta cap r minus beta dash. So by putting this value of beta cap r minus beta as m x dash x का inverse x dash u, then we will get expectation in bracket m x dash x का inverse x dash u in another bracket, since we have taken dash, so u dash x double dash equals to x and x dash x का inverse dash which is equals to x dash x का inverse and m का dash m dash. So comparison with OLSC of beta, which is m x dash x का inverse m dash